Okay, so hello everyone. Nice to have such a big, wide, and diverse audience here. So thank you, Grace, for introducing me. So again, I'm Gedris. I'm technical product manager in the Velo family of products, which includes Velo itself. It includes Wix Data, which we're going to be talking about today. So today I'm going to talk a little bit about what's important to know when your database grows and how to go about it, how to model the data, what are the data retrieval strategies, what tools do you have to make sure that your site continues performing as it grows. So when considering the scale, you need to think what you're going to have a lot of. So it could be a lot of visitors. So even if you don't have a lot of data, just the sheer amount of visitors can put strain and resources on your site. It's maybe a lot of computations that you're doing, whether it's a lot of computations because of a lot of visitors, or you just need to do heavy lifting, a lot of heavy lifting to serve a few users, and obviously the amount of data that you have. And so we're going to cover a bit of all of these to sort of give you strategies and tools to deal with these issues as we go. So when modeling for scale, the main thing to know is what matters is the size of data, it's the size of bytes. It's not the number of items, it's not anything else. It's really, you want to minimize both the bytes read from the database and bytes transferred over the network. So to illustrate this, I want to talk about how is data query executed in the database. So what happens if we have a collection of items and you say you're running this Wix data query and saying, okay, I want to query the collection. I'm going to filter and I'm going to find all items where title equals word. Now, what database has to do, it has to go through all of the items that you have in the database, right? It's going to read the first item and say, okay, if the title matches, no. Continue to the second one. Does the title match? No. Continue to the third. Okay, title does match. So I'm including this item into the result set. And I'm checking the fourth item. Does it matches? No. And it's going to read the full database. So whether you have 10 items or you have a million items, that query is going to by default read the full database. So this is why your queries will get slower as your data grows. Now, why is it bytes and size matters more than the items? Well, you can have 10 items that are 100 kilobytes in size, or you can have 100 items that are 10 kilobytes in size. The total size is 1 megabyte. And this is what matters. This is what gets read from the disk in the database. And you can expect to be performance roughly the same. So that means your performance will correlate more of the bytes being read from the database and not the necessarily number of items in the database. So the main strategy, the main thing that we need to be thinking is, how do we read rest from the database? How do we make sure the database doesn't do the excessive work? And the most powerful tool that we have for this is the database index. So these didn't exist since the beginning. We have added them a little less than maybe 2 years back, because we saw that sites that are being built on Wix are becoming really high scale, and just not having this tool in our toolbox for our users is making some sites impossible. Now, with database indexes, you can optimize your database and you can optimize your read speeds in a way that data size matters much, much less. Now, the way it works is that defining an index on some fields creates an additional data structure, just like an index in the book, where database is now able to quickly look up items that it needs to. So it's a tree-like structure. I'm not going to go into too much technical details of what it actually is, but it's a tree-like structure. Let's say if we have this query, we're saying, okay, let's find an item where title is third. So it goes to that structure and sees, okay, so the items that are alphabetically smaller or resident are going to the left, and items that are bigger than second going to the right. So I can exclude not checking these items and quickly go to finding third in that data structure. Okay, have a pointer to that item and quickly returning it. That means I can omit checking all the other items. I can quickly locate in the index the value I'm interested in and read just those items. So I'm not reading from the database neither first, neither second, neither fourth, and I can have a lot of more non-matching or matching items in the database. I'm going to read and check only those that have that specific value. And I found out that by reading a much, much smaller data structure than the full database, than the full collection that I have. So if I have an index on the title field, now I can do multiple operations that are going to be faster. Equality is obviously faster because I can find that value fast, but also filters like greater or lesser or ordering operation, like I can sort by title, is going to be much faster just because I have an index. Why is that? Because the index is also a sorted data structure, that is, all items in the index are sorted. If it's numeric value, it's going to be sorted numerically, 1, 2, 3, 4, 5. If it's a textual value, it's going to be sorted alphabetically. And given that those items are in order, now such operations like greater become really fast, because I know if I'll find the third, all the items after it are the ones that are matching the query. So I'm just traversing the index in order and getting all the items that are greater than this value alphabetically. And the same goes for sorting. Now, items in the database are not sorted by title. So if a database had needed to give you items in order of the titles, let's say you execute this query, database would have to read a lot, potentially all of the table, to find those 50 items, which is the default limit for this query, that are alphabetically first sorted and give it to you. So that's a lot of data to read. Now, if it reads from the index, we know that the first 50 items in the index are the ones that are alphabetically first. So this is exactly how much items would be read from the database, which is much, much faster than going through all of the table and reading all of those items, really. So how do you define that index? Now, I've talked a bit high level how it works, but defining index is very simple. If you're in Content Manager, if you go to more actions, you go to indexes, you're going to be presented with index UI. And there we can choose to select to create regular or unique index, and then define this field. Now, which index type to choose? Regular, as it says, is regular index. It's used for accelerating queries, accelerating filters, and accelerating sorter. Just as I said, they can contain multiple fields. There's multiple regular indexes you can add. Now, unique indexes have a second purpose. They will also accelerate your queries, but they are limited to only one field. And unique indexes make sure that the values in that field are unique across that collection. So it's good for things like, storing emails or whatnot, like user contacts by email or something that's unique about that user, or any other object like cars by their VIN number, where I'm making sure that they don't have duplicate values in that specific field. And if you were to try and do insert operation where that value exists, such check would quickly happen because we have an index on it, and such an operation would be rejected. Now, generally, what fields to include after we've chosen which index type depends on the query. So really, you should be looking into queries you have. So the most common queries, the queries that you find to be slow, and index and put index on those fields that are being used in that query. So first thing to know, you get some indexes built in. An ID index. This is something that exists in every collection. You may have noticed that you have an ID field always is indexed. This is the default index. It's always unique. Generally, we auto-generate this value because we don't know what your subject key is. But it's a very good idea to make use of it, because when it's free, you don't consume any extra resources. It's always there. So you can put meaningful keys, just like in unique index, a meaningful unique identifier for those items, and then make use of this index, because finding by ID, ordering by ID is going to be always fast, and this is the fastest index you have. There's also extra index on created item ID. If you've noticed, if you don't specify with data any sorting order, whether you're in CMS or executing a query or showing items via dataset, you'll notice that the items appear in a certain predefined order, and that order is created date. And if some items share created date, it will be broken down and sorted by ID within that scope. So this is to make sorting faster, and you also have this index. So if you will also filter by created date and say, give me the newest items, give me something that's created after this date, these operations are also going to be fast because you have this implicit index already from the system. Now, let's go through a few examples. Let's say you have this query where you call querying a products collection, and you want to query by category, and in this case, you're querying by price, and you want to find something. So obviously, you're going to define an index that includes those two fields, category, price. Now, indexes have order, so this is commonly used to accelerate ordering operations. So if you have sorting, ascending, descending by that, so we'll want to sorting order to match this. But if you're just filtering, it matters a bit less. If you're doing greater or lesser, then again, it may. That's it. If you have equality filters, you define index on those two fields, this query is going to be super fast. Now, but it will also look greater. You can take the second field and you can say, okay, I want everything in category fruit, but I only want items that are more expensive than 139 in whatever currency you prefer to store your items. This will also work because again, we can find the 139 or the first item that's greater than this value if it doesn't exist in the index, and then retrieve all of the others again from the index because they are ordered by that. So all of the bigger items will be indexed in the index next to each other. And so best way to visualize it is to imagine that the index is a phone book. Really, if you've ever seen this old invention of the phone book, from times where data privacy laws were less strict and we couldn't know this data about anyone. I remember when I was a kid, we did have phone books, and they were issued, I think, every 2 years. Post office would deliver one to your home. And they were usually ordered first by last name, and then by first name, and then they had, your phone number. In your region, it may have been different, but most look something like it. So the phone book is an index on two fields. First field indexes your last name, and the second field indexes their first name. So if you want to find, Beatrice Taylor, that of course you have to look up by the last name because it's the first field index, and then you're going to quickly find Beatrice because it's the second thing order. And if you want all of the Taylors, again, it's very easy. You can query just by the Taylors. You're going to find the first Taylor, and then everyone subsequently is the Taylor alphabetically. So the same works with indexes. If you had an index on two fields and say, I'm going to query only by the first one, I'm going to find all of those values, and they're going to be efficient because all Taylors, all values of the first index are next to each other. Subsequently, what's to know is that finding something by the second field in the index, let's say if I wanted to find something, that's by price or by greater price without specifying category, wouldn't work, just like in the phone book. If I wanted to find all Theodores, well, I can't because Theodores are all over the place because they have different surnames. It's first we sort by surname and only then by name. So such an index wouldn't help. It's exactly the same principle in the database. As in that example, just sorting just by category is going to be accelerated by index, and it's going to be very fast. And just doing it by price will not. Now, this also works with ordering. So because we have a category, we filtered by it. So we went to a specific fruit. Then we can get all items in ascending order in price. And it's going to be fast, and it's going to be efficient. And it's efficient, again, because all the prices are in increasing order. So even if there is, a million items in category fruit, we're going to be able to efficiently take them one by one in order and give it to you. Now, if you ever ran a very big database, you might have gotten an exception saying data set is too large to order. And when we're reading from database and ordering items, we're putting them into memory, basically in RAM. And there's a limit of how much of that memory we have. So if you're doing a very expensive ordering operation, which is expensive meaning on a very, very large collection, we may run out of memory trying to read all the database and sort it. Now, if you have an index and sorting by index, it never happens because we just read from the index in order and fill your result set and send the data to you. Yeah. And again, to order queries wouldn't work. Now, if we're saying greater categories, I want our categories, but everything within the category is going to be ascended in price. Now, the database cannot just read prices in this descending order within the category because it's not just fruit, it's all other categories. And between different values of category, prices are not sorted, so it will sort in memory. So in this case, it will not work. Yeah. So indexes are your main trick. If you have large data set, you need to be looking into your queries, the queries that happen often. You have, based on your plan, you may have limited number of indexes. So again, you need to optimize for those that are most common. Those are going to relieve your database resources. Those are going to be the fastest. Now, besides indexes, there are other tricks that you can employ. For example, counting. Like every Wix data query, if you'll notice, when you're asking for something, it will give you the results, the items that you asked, but it will also give you total count. So if we have, just like in this example, 10,005 items matching the query, we only read 50 items because that's the default limit to fulfill this query or whatever else limit you may specify. But we're also going to do a second query to count how many items in total are matching your query, which means that second query is actually reading all of the collection to find out all of the items to find out how many are there. Now, if you have an index, counting is also very efficient because those values are next to each other. They're very inexpensive to count from the index. But if you don't have an index, this may become expensive, and you don't always need that count. So the trick that you can do is you can omit the count operation. So it will both make your data operation faster, and it will consume less of your resources. And if you only care about traversing all of the items that are matched in order, we're going to give you an indication that, yeah, there's more items. That's it. So you make your query, up to twice faster just by passing this flag, provided that you don't care about total count. If you're showing paging numbers and you want to allow users to skip to a specific page, the same applies to the data set. If you have the paging component, of course, you cannot use this mode. But when you just want to allow users to traverse sequentially, like you only have next and previous buttons to show your data set, or you're doing like lazy loading, which loads more and more resources, then this is an amazing optimization. I mean, it's one flag to make your queries almost twice as fast. Another trick, again, remember, the most important thing is how much data we read, is making items smaller. So sometimes you may have a very detailed catalog item. Let's say if you have a catalog, if you have a store or some product catalog that you want to showcase on the page, then you're likely to have a lot of information about it. It's like, let's say it's a flower pot, you'll have a link to images, maybe the full gallery stored there. So, gallery will store links to every image in the gallery. You'll have price, materials, you'll have description. Descriptions are often long. It's long textual information. It's rich content or rich text type. These tend to take a lot of space. And so such item may be slow to load, but you only need it if you're loading the product detail page. But often when there's the detail page, there's usually a listing page, like list all projects or list all projects within categories. And they show little information. Like they show maybe name, maybe category, maybe they show quickly the price. and then you have more details button. So you could easily split that collection into two collections, where one is small, so it's going to be very fast and easy to traverse, and one is big and only traverse when you need the full item. And when you need a full item, you can create a dynamic page based on ID field, which is always fast, and you can get away with loading a lot of data very fast without even defining indexes. And your listing is going to be fast just because your items are very small. You can often automate this. So obviously you don't want your users to manually, go into CMS and enter the full information and then go and enter small information. That's not very user friendly. But the trick you can do, one is you can create a hook, like on insert or update of the full item. Just create a projection of the fields in a different collection that you've created. It's on insert and on update. Insert or update the listing item collection with a smaller set of information. Second trick, you can run a cron job in Velo. You can write jobs that run every night and just rebuild those listing items. So it has a problem that is going to have some latency. The changes are not going to be immediate. You can sometimes do a different trick. Another thing that can be slow is doing a lot of includes or joins, as they denote in or lookups in other databases. So if you have a catalog, let's say my data model is, I have a catalog item, but it has the categories and has some options items, warehouse information, availability, something that is joined from other collections. You have a lot of references and multi-references. Now, joining from other collections is generally a bit more expensive. The references are by the ID field, that's implicit index, so they are as fast as possible. But if you have several includes, it will inevitably slow down your query. So in this case, you might want to do it in opposite. If you're finding yourself that a lot of your collections need to join or include a lot of other collections, you may want to create another collection that has embedded those objects inside of it. Again, user in CMS will see, this is 4 different collections, but you may create another one, synthetic fifth one, that unhooks rejoins the data and stores the full object inside of the collection. It's another thing to remember about the data model of Wix data is that it's a document store. Although in CMS it looks like, like a table, we present like a table as it's a convenient model to work with. But you can always store any JSON you want. So, you can include options array, which includes other objects from other collections, and you can specify options as an array and see it in the CMS. So you have ability to store everything you want. And then if in such a pre-joined collection, you don't need those extra include operations, and this is going to be faster. Yeah, it's a lot more data, but still reading a lot more data from a single collection will often beat reading the data from the different ones. Again, it doesn't probably worth the effort when it's an occasional query, but if it's a dominating query where you includes in the main flows of your user of the site, front page or something that's important, you may want to consider this technique. And another maybe less known feature, but even if you have those objects, you can filter by them, which is sort of a hidden benefit of having such a collection, because typically when you're using includes, Wix data doesn't allow you to filter by the objects that you're including. So you can only define filters on the primary collection, in this case, catalog. But if you have everything nested in the same collection, the same item, then you can actually filter by those nested in fields, whether it's in an arrays or in an objects. You have this dot syntax where you can deeply access properties and write filters just as you would for any other field that's at the top level. So this concludes my tricks. Generally, now I want to talk a bit about Wix request lifecycle and a few other things in data that you can optimize for. That's going to help you make the sites a little bit faster and sometimes save on database resources. So whenever your user visits the site, user will go for the internet, is going to reach our first data center that we call micro points of presence, and then it's going to go to our main data center. So this architecture may sound weird, like why does Wix need two types of data centers? So one, this is main data center that has all of your data. This is where Wix data lives. This is where our database. These data centers are in, legally and otherwise safe locations. And this is where most of bulk of your data exists. And these are much smaller data sets that are meant to be closer by users. There's a lot more of these than there's of these. When you generally reach such a small micro data center, all of the subsequent traffic, all of your connections and data fetching happens for network that Wix owns. We are renting it from our partners or otherwise owning this capacity. So this is very fast. This is like premium network here. So we're trying to capture public traffic as soon as possible and then send it to our main data center in the fastest way possible. Another feature of this is that this is where the cache lives. If you guys know, Wix will try to cache rendered versions of the site, like the HTML that we can serve very fast and that can be rendered by the browser extremely fast, so that the users get first visible page as soon as possible. So these are closer to the user, and if we have a version of your page here, it's going to be served to the user very fast. For other resources, there's a similar architecture, less relevant to us. We have the CDNs. There's even more of these, where this is where the static resources live. Static resources like images, like your Velo scripts that you write, are typically within the country or neighboring country of where users are. There's really a lot of CDN nodes, and the bigger countries, there's multiple, so that we can serve you optimized resources as fast as possible. Now, this is where the scaled images, mobile versions of images where they're smaller are going to be stored and whatnot. So when coding, there's a few things to know about cache. One is, cache is stored for 7 days. It can sometimes expire sooner because of changes. So, for example, if you change the database and the page is referring to the database, for example, it's a dynamic page, we're going to invalidate that cache and remove it from micropop so that Wix will render a new version whenever next time user will view that page. One important thing is that pages with Velo code, like non-empty, unready functions, something happening, you're running your client-side code, will not get cached by default. So you should be going, if you want cache mechanism to work, you should be going to page settings and forcing that cache in this case, and saying that you want manual control of the cache, and then saying, I want to cache that page. Now, you probably have noticed if you ever built, for example, a router page in Velo, or generally some client-side code that, for example, logs visitors or logs something to your logs, you might have noticed that visiting a page produces 2 logs or 2 data access operations or logs 2 user visits. Now, this happens because to get that fast version to the users that browser can render immediately, we do heavy lifting in our data centers. Like whenever the first time user will visit a page that has some Velo code, or even if it doesn't, we're going to do what's called server-side rendering. So we're going to run all your JavaScript and everything to render the page, to join it, build HTML for the browser, and then we're going to send that HTML to the user. Now, this is faster because all of the data, all of the required calls, everything can happen within the data center. It's very fast. It's much faster to render that page, even if you're doing multiple Wix data calls. Their data is here. So running those calls is very fast. And then we send them through the internet. Now, if user runs a data call from here, your client-side code does Wix data query, this is a longer round trip. So we're going to do first render here. We're going to send that page. Now, the page is eligible for caching. let's say you turned on caching on that page, we're going to store that pre-rendered copy on this micro point of presence. And that means next time any client within that location is going to open that page, we're going to serve that pre-rendered version very, very quickly because it's already done. It doesn't have to go for that pre-source. So it's going to see first visible version quickly, and then client-side rendering will kick and will execute your code so your page becomes interactive and essentially render the page. So enabling caching your pages is a great way, is one, to preserve resources, because if you're not running server-side rendering on subsequent calls, and you're able to serve cached versions to your users most of the time, you had just divided by almost to your database use, right? So you're making less calls, and you're also making your pages faster. So caching is really, really great for improving the performance. Now, something to consider is what you include in the cached version. Now, whenever we're doing unready and we're doing server-side rendering, we're going to wait for you to render the page. So essentially, we will send the rendered server-side render version to the user once it has completed rendering, and we know that this callback you pass on ready, this is probably something you have in your every front-end page, has completed. Now, if it's only synchronous things, we're going to wait for it to exit. If it's an asynchronous function, that means you're running some operations, you're waiting for other promises and whatnot, then we're going to wait until this promise is completed of this function. So this function returns a promise, which is going to complete once we have waited for this. You can do this, you can return the original promise written by that action this way as well. Wix data itself also returns promises. But the trick is find the mistake here. Here, I'm setting label based, on how many items are in this collection or in this result set, but this may not be part of the server-side rendering. So the user might not see this value of this label because I'm never instructing on ready that it needs to wait for this promise to complete. So now I either need to return this or add a sync and await here so that Velo knows to wait for this query to complete. And knowing this is actually a very good trick. So in ready, you can wait for actions that matter and not wait for actions that don't matter. So for example, if you're loading multiple points of data, let's say you're loading a page and you're doing 3 data queries, but you know that only 2 produce results that are initially visible. Let's say you need to scroll down, way down to load data that's coming from the third query. Don't wait on it. Don't have server side keep the user waiting. Don't make it a promise that you wait, or don't even execute that call. Only execute what's visible. You're going to give the initial version of the page faster to the user, and until user does something, scrolls or moves on in the page, the client-side rendering has kicked in and actually rendered what's not visible. Another trick, this is built in the data set. So if you're in a dynamic page or another data set and you have code enabled in your site, you will actually have a checkbox that allows you to lazy load data, which is doing the same thing. It's saying, okay, don't load that data, don't stop, don't wait for that data to be loaded to actually do the initial rendering for the user of the page. Load it later. So when you're looking at a lot of data and some of it is not visible, it's a very good and easy tool to just enable that checkbox. And so user quickly sees the page even before that data is loaded, and data will initially be loaded until the user scrolls. Usually the delays aren't that big, but user can begin to see something. Yeah, so when you're considering what to execute in SSR or what not to execute in SSR, so good candidates are data that are not being immediately used. Let's say something that's going to be visible after you expand the section, after you scroll down, after you click a button, after you hover something with the mouse. All the data that you need in interactive actions, you should exclude from initial rendering. So that's data you're not going to be loading initially, not going to be stopping user from getting the page and making him wait longer, is great. Loading heavy data. Sometimes it's something that may be visible, but it's really heavy. It's really a lot. You may want to maybe put a loader instead of it, and then just load it dynamically. If user can already do something with the page, if there's some text, if there's something to read and see, then maybe doing data that is going to capture user attention later on the site life cycle is fine to have a loader. Now, of course, it doesn't apply in the cases where the data is the only thing visible. Obviously, you will want to load it even if it's heavy. Another thing, if you're deciding where to render, you can just, one option is to not await on the promise of those actions. It's going to be then your luck if it loads or not. You can skip it altogether and say if rendering environment is browser, only then include that lazy loading. And that means nothing you put on the safe is going to be rendered on the server side. So everything you put here is going to be rendered only in the client, and that means all of these things will not be preventing and not be slowing down the first render of the static version of the page. But this means that it's also things that are not going to be included in the cached version. That may also make your HTML smaller and quicker to transfer because there's less things on it. Okay. So again, backend code runs here and the page goes here. Another trick to consider is where do I render things? Right, so you have methods, you have ability to run data queries both in client and backend. So one thing is if you want to fetch data, you can obviously run Wix data query on the page code and fetch it. But as I said, the problem is that there is this whole round trip going through the internet from Microsoft data center, fetching the data and fetching it back to the user. Now, if you're doing a single query, it doesn't really matter. You have to go to the data center. That request will have to go from the user browser to the data center. But in some cases, you may be doing multiple data queries. Let's say you're you're issuing one query, then based on the results of it, you're issuing a second query, and based on the results of it, you're issuing a third query, maybe calling some other Wix API to get extra data that's not in Wix data, and then you're transforming that result and displaying it to the user. Now, if you have subsequent requests, it may make sense to not do those requests on the page code, because every time you do a request, one round trip. You do second request, second round trip. You do third request, third round trip, right? This latency between the client and our data centers, depending on where the user is, may be big. Maybe we know hundreds of milliseconds. Not all of your users will live close to our data centers. So in that case, it may be better to create a web method, a backend code function that runs all of those queries. So you do round trip one, you go here, backend code runs in our data center, doing all of those queries, calling Wix data, calling other Wix's APIs. Those calls are much faster because they don't incur round trip. Everything is close by. It's in the same or adjacent data centers. It's milliseconds of extra overhead. You do that heavy lifting. You form the data. You may also choose to drop the fields that you don't want to transfer, saving on data transfer, and then send back the result. So when you have this big data load process, you may actually make it a lot faster doing it all in the backend and just fetching it with one call. And this is a technique that we often recommend to our users because they would come to us, for a consultant and say, okay, we have this page, this is very slow. What we'll look at is they have 5 or 6, subsequent calls. And while individually they aren't very slow, but based on user location, this round trip just from the client browser to the data center becomes very big, and those latencies compound. And then we say, simply just move everything to the backend function data center. Do one call there, do everything on the backend code, and it's going to be much faster, and it's a great help. So again, client things, you will want to put something, that's for interactive, that calls public APIs, or the requests are parallelizable. We'll talk a bit about this later. But if you have a lot of dependent calls, if you're processing data and you're stripping a lot of data, so you don't use most of what gets fetched from APIs, backend is a great idea, because you can also, fetch a lot of data, minimize it, send the bare essentials that needed by the client. And obviously, anything that needs any kind of security can only be enforced in the backend.
Yeah.
Another thing that we often notice that users overlook is independent calls. Like if you look at this code example, imagine this could be two data queries, this could be something else, and we're using async await. We're fetching some image, we're fetching related, and what await does, it puts all of those operations together. It means I will fetch the image, and once this operation is completed, JavaScript is going to proceed to call fetch related. Even though if image is not used by this function, if it's not actually related, we may want to execute these in parallel. So this will make it a lot faster. Like I can use promise all, for example, and say, run these codes, then wait for both of them to complete. That means these will run at the same time, and the latency to go from user browser to our data center, actually completing the query and going back, is not going to compound. So watch out for these little points of optimization where you can run things in parallel and make it a lot faster. This is something also that we sometimes show to our clients. It's like, oh wow, this is much faster. We get some response. I didn't think about it, but wow, that's a great technique. So this is something we saw quite a lot, and I really wanted to share with you in this presentation. Or again, alternatively, if you don't want like promise all function, you can invoke the function and say, once it completes, do the thing. So it's going to, those two operations are going to become completely independent. That means, once fetch image completes, then I'm going to run my update image function and set the image to the property. And once this function is completed, no matter which one is first, I'm going to immediately react to its result and do what's needed. Again, in this case, also both will run in parallel. And now that we're done with the tricks, if site has a tendency to grow, you may want to monitor the situation. So just one reminder, you do have monitoring tools, which will start to show when you're growing. Because often what happens, your site is not big when you're created. Sometimes your user may already come with a big data set and say, okay, this is all the things I want to do and want to show. In this case, you know that the site is going to be big, and you can prepare for it, create appropriate indexes, create appropriate strategies to deal with the volume of data that you have and make queries fast. Now, sometimes the user can create data as they go. Maybe they import data from external sources, grow there. Maybe user is creating data as it goes. Maybe the interactions within the system itself are producing data that's getting slower and slower. And user may complain, okay, my site is becoming slower. So a great tool is to look at the monitoring dashboard and see, what's happening with the site and why is it slower. Because it might have been fast months back. So one thing to look out is latency increase with increase in RPM, which is probably because we're waiting for CPU time. If things are getting slow in container, you may want to see how to optimize the code or upgrade the plan. Another thing that you may notice is that you're going to get specific errors. You're going to get timeouts, you're going to get operation time limit exceeded. So again, easy option is to upgrade the plan, and say this is it. We're now in Velo giving you more options to grow your site and get away with these limits. Again, because we're seeing that more and more sites, big sites like data-heavy sites, are getting built on Velo. But also, first thing to do should be like looking at optimization techniques. Can I add indexes? Can I run queries in a smarter way? Can I run less of them? Can I pre-build other collections to make my data querying faster, more efficient. And only then you can think about, okay, so I've exhausted my solutions. I actually just need a bigger plan to serve my site. So this is some errors to look out that you're going to see in monitoring dashboard that's going to say, okay, the data size, the compute size is outgrowing the current plan or the current design of the system. And that concludes my presentation. Thank you for those who have survived. And if you have any questions or interested in anything Bell or Wix data related, I'd be happy to answer.
Awesome. Thank you so much for sharing more about planning for scale on Wix Studio. Now we're going to dive into some of our top questions that we received throughout the webinar. So the first question that we have is, I'm using an SQL database. How do I refer to it in programming?
Yeah, so you have broadly two options, and it depends on what you need. So whether you just need to run a few SQL queries from the code, then if it's exposed on the internet, you can use Velo packages. There's a MySQL client, there's Postgres client. For most SQL databases, we have packages available. You just import that package into your site, and you can start connecting to your database. Obviously from the backend code, because you're going to pass your credentials on login, and that way you can expose your data. Option number two is if you want to use data binding and you want to use CMS tools with that database, then you can use our external database offering. So what it does is we have adapters for common databases, again, for Postgres, for MySQL, from Microsoft SQL, that you can deploy next to your database, and you can make your data available within Wix Data itself. So you're going to be able to access your SQL database as if it was a Wix Data database. It's going to show up in CMS. It's going to be available for data binding, data dynamic page creation. If you need that, I suggest you look into our external database adapter offering. I think if you're going to Google Wix external database adapters, it's going to lead you to the documentation that's going to show you, hey, here's the setup one. But if you just need to run a few queries, you're always good with just NPM module that connects to your database.
All right. The next question that we have, and I'm answering them, or I'm typing them in the chat, by the way, so that everybody can read them while we are saying them out loud. But next question is, every time I think about how to set up things to scale on my website, I get overwhelmed and end up just doing the minimum so I can move on to something else. Do you have any actionable small steps you'd recommend?
Yeah, so it's things that we included in this presentation. So one thing that I would think about, what are the most common queries that are on the collections that will tend to grow with your site, and just put indexes there. As we walk through it, indexes is your number one thing. If you know something is going to grow, you can think in advance and say, okay, I'm going to put indexes there, and that. From there, you can think about other strategies. You have like really large tables where I use very minimum data from. Then you can use the splitting trick and whatnot. But really, the first thing you should consider is indexes until you know nothing. And most other optimizations sort of come up when you start having issues, and then you react to them by doing something.
Okay, next question. I've started to hear about some AI tools for data viewing, sorting, etc. Are there any that work for you that you've heard of?
For data sorting. So we're at Wix now looking at all kinds of AI solutions. So we're by the way, there's a AI plugin in Velo. So if you're using Studio and you're using IDE, you can notice there's a helper plugin that helps you write code. So do check that out. In terms of data accessing, we haven't used any tools. We have experimented with this with Wix Intelligence. Can I say about that it's coming? I'm not sure. I will not spill some secret, but we have something cool in store in AI-wise, which is also going to be able to analyze data that's on Wix data. But I don't want to spill more beans now because I don't know if it's public yet.
Yeah, stay tuned. Okay, next question we have. I see the cache is stored for 7 days, and thank you for sharing the invalidation process. How do you set a different cache for different collections? Meaning keeping the 7-day cache for the list of users makes sense because it doesn't change often. How about a product list where the quantity should be updated often? Is that part of the invalidation process?
Yeah. So if you're base something, if let's say if your product item is a dynamic page, whenever we have data sets, if it's referred by the data set to that collection, we will actually know that you have changed the product and that we need to invalidate specific page that reference to that collection. So just try to load data by data set, whether dynamic or regular data set. And whenever the item changes, we're going to purge the cache for those affected pages within seconds. So that we don't store everything to 7 days. If we can detect that there was a change, we are going to purge cache sooner. This is true for Wix data. This is true for Wix stores, Wix bookings. For most of Wix products, they know they track data changes and they will remove affected pages from the cache immediately as the data changes happen.
Awesome. I think those are all the questions that we have for today. If you have any additional questions, feel free to go to the new Wix Studio forum. I've just sent a link. And join the Wix Studio Discord community, and feel free to ask away there. Our product managers are more than happy to help you out. And of course, our academy is always there as a resource for you to get more information. The recording of this webinar will be uploaded to our academy and YouTube channel, so you can watch it later. Also, if you have any feedback from today, please let us know in the feedback form, which is linked in the chat. And thank you so much for joining us today. Bye, everyone. Take care.
Thank you all. Bye.